Curve sketching. Slope and equation of tangent. To find the slope of the tangent to a curve at a point x1, y1 on the curve, step 1, find the derivative dy dx using whatever methods are required. Step 2, evaluate dy dx at the point x1, y1 to get the slope, i.e. m, the slope, equals dy dx at the point x1, y1. If the equation of the tangent t is also required, we use the equation of the line formula, y minus y1 equals m times x minus x1, to get the equation of the tangent. This is from our coordinate geometry section and it's in the formula book. So this is our x-axis, this is our y-axis, this is our curve, and this is the tangent. The line t is the tangent to the curve. A tangent touches the curve at one point, and this is the point x1, y1. So m, the slope, is equal to dy dx at the point x1, y1. So find the equation of the tangent to the curve, y equals x squared plus 3 over x minus 1 at the point 2, 7. So first thing we want to do is differentiate our curve. And since we have a fraction, we use the quotient rule to find dy dx. So this is the quotient rule. Our numerator is the u, our denominator is the v. So we write down the v, which is x minus 1 with brackets. Then we get to u dx, so we differentiate u with respect to x, so we get 2x with brackets. Then we have a minus. Then we write down u, which is x squared plus 3 with brackets. And then we get dv dx, which is the derivative of v, which is the derivative of the denominator, which is 1 with brackets. And that's all divided by v squared, so all divided by x minus 1 squared. Next we multiply out the brackets. X by 2x is 2x squared, minus 1 by 2x is minus 2x, minus by x squared by 1 is minus x squared, minus by 3 by 1 is minus 3. And this is still over x minus 1 squared. Then we simplify. 2x squared minus x squared is x squared. Bring down the minus 2x and the minus 3. Now we've simplified as much as we can. So we're interested in the equation of the tangent specifically at this point 2, 7. So since 2 is our x value, we swap each of those x's for 2 with brackets. So m is equal to the slope is 2 squared minus 2 times 2 minus 3 divided by 2 minus 1 squared, which gives us minus 3. So now we have the slope at this point. Now we just need the equation of the straight line, the equation of the tangent. So the equation of the tangent is y minus y1 equals m times x minus x1. We swap the y1 for 7. We swap the m for minus 3. And we swap the x1 for 2. So we simplify. So we have y minus 7 equals minus 3x plus 6. So 3x plus y equals 13. Or solving for y, we could say y equals minus 3x plus 13. So this is the equation of the tangent. Let f of x equal x cubed minus 3x squared plus 12x minus 5. Find the coordinates of the 2 points on the curve y equals f of x at which the tangent to the curve has a slope of 12. We need to get dy dx, the derivative, which is the general expression for the slope. Then we'll put dy dx equal to 12 and solve this for x. Then work out the y coordinates of the points. So our curve is y equals x cubed minus 3x squared plus 12x minus 5. Dy dx, the derivative, is 3x squared minus 6x plus 12. So we let dy dx equal 12 because we're told that the curve has a slope of 12. So we let the derivative equal 12. So we have 3x squared minus 6x plus 12 is equal to 12. So we cancel out the 12s on both sides. So we have 3x squared minus 6x equals 0. We divide across by 3, so we have x squared minus 2x equals 0. We factorize, so we have x times x minus 2 equals 0. So let this x equal 0, so one of our x values is 0. and then we let x minus 2 equal 0, so x is equal to positive 2. So now we have two x values. We substitute both of those x values back into the original equation. This is very, very important. Back into our curve, back into f of x. We do not substitute it into the derivative. So if x is equal to 0, y equals 0 cubed minus 3 times 0 squared plus 12 times 0 minus 5, which gives us minus 5. So 1 point is 0 minus 5. And if x is equal to 2, then y equals 2 cubed minus 3 times 2 squared plus 12 times 2 minus 5, which is 15. So the other point is 2, 15. So we were asked to find the coordinates of the 2 points on the curve y equals f of x, at which the tangent to the curve has a slope of 12. And those 2 points are 0 minus 5 and 2, 15.